Hello everyone, welcome to the Soft Computing Practical Series. We will study about the radial basis function. So what is this function is? So a radial basis function, that is called as RBF, is a real valued function whose output depends only on the distance between the input vector and the center point. That is the radial part. So consider this graph where we have some values x on the x-axis and the phi, the function, the real function on the y-axis. So this behaves in this way. So this is an example of a radial basis function. So let us see the equation, how does it behave. So this phi of x is given by this exponential equation. So suppose in this equation, what is sigma? Sigma is the width of the particular, how much it is spreading, how much this function spread is given by this sigma. And we have the center point where we have the maximum value of the function. Now suppose if we consider a point x1 on the x-axis, so for x1 the value of phi is calculated by using this formula, and of course it will be this particular value. Now this is the, on the y-axis we get the value of the function. Now suppose if we move more closer to the point C, that is consider point x2, again we use the same formula for calculating the value of phi using the value of x2, and this is the what we are getting the value for x2. So as we move closer to the value C, the function increases exponentially. So this is how the radial basis function works. So this function will be used as the activation in our case, so that when we give it the input, we adjust the weights using this particular activation, so that a particular neuron gets fired when we give the particular input. So we will be using the XOR example. So for XOR we have 0 0 is 0, 0 1 is 1, 1 0 is 1, and 1 1 is 0. So let us now see the Python program, then we'll execute. So this is the Python code where we implement the RBF algorithm for XOR. So this is the step 1. This step 1, it defines the Gaussian radial basis function, where there are this is the center and the sigma. And then we have step 2. This step defines the RBF network class. So these are the things we are defining in this case. Then in step 3 we define the XOR data set. So here we have, this is the input array. So input, because there are two inputs, so we can make 4 combinations: 0 0 0 1 1 0 and 1 1. And for 0 0 output is 0, for 1 0 output is 1, and then next output is also 1, and for 1 1 we have 0. So we must get this. Then we define the RBF parameter. So sigma value we are taking as 0.5. Next step, we initialize and train the RBF network in this particular step. Then we test for the predictions. As we know, the predictions are 0 0 is 0, 0 1 is 1, 1 0 is 1, and 1 1 is 0. So we are testing the predictions here, and then finally we display the result in this step. So this is the final step, and then of course we can this is the optional part. So let us see this. So this is what we will be getting. Okay. So let us now execute this on Google Colab. So now we are into the Google Colab. I'll just click on this code. I've already copied the code. I'll just paste it here. So this is the required code. Now let us run the code. I'll just click here to run the code. So now we are getting the output. Let us check the output. So this is what raw outputs, this is what we are getting. So 0 0 we are getting 0. So prediction is 0 and actually is also 0. So 0 0 output is predicted and we are getting output as 1. So 1 1 0 1 0 we are getting 1, and also actually we are getting 1, and prediction is 0 for 1 1, and output is also 0. So these are the raw outputs, the last step. Okay. So this is how we execute this particular RBF using Python. So that's all for this session. Thanks for watching.